Let's just talk about what it means to be a derivative by looking at a graph. So here's the graph of f of x. F of x looks like a cubic graph, and you'll notice that it increases from negative infinity. It increases from negative infinity all the way to this point right here. Let's call that negative 1. And then again it increases from, let's say, 1, 2, 3, 4, 5 and a quarter, let's say, 5 and a quarter to positive infinity. That's where it's increasing. And then it's decreasing from this point, negative 1, to 5 and a quarter. Okay, so that's what's happening with the graph. Now, what does it mean to be the derivative? Let's do the derivative in purple. So f prime of x means the slope of the tangent line at x. So if every single one of these points right here, what's the slope of that tangent line? Look at the tangent line. It's a positive slope, right?
Yeah.
How about this point right here? What's the slope?
Positive.
It's positive. How about this point right here?
There is no.
The slope, there is a slope.
It's just 0.
It's 0, right?
Mm-hmm.
So the slope is 0.
Mm-hmm.
How about this point right here?
Negative.
The slope is negative, right?
Mm-hmm.
How about this point right here?
It's still
Negative. How about this point right here? 0. How about this point? Positive. This point? Positive, etc. So what are we doing when we're talking about the derivative? We're talking about the slope of the tangent line. We're talking about the rate of change. You know what it's like doing? It's like turning this red graph into a bunch of lines, which is really awesome because lines are much better than curves, because lines have slopes, which are one number that talk about rate of change. That's what a derivative is. So the question I'm asking you is, what does this have to do with why do I always set this equal to 0 to find out where it increases and decreases? Because wherever this equals 0 are your max and min points for a basic graph, for like a polynomial graph. And anytime it's negative, this is where that slope is negative right there, right? Because it's going down. That means it's decreasing. Anytime f double prime is negative means the graph is decreasing. See how the graph is going down? That's what you're doing. So that's the concept behind that. So let's graph f double prime right here. Let's go ahead and graph it on the same coordinate axis. The slope of that is what?
0.
So there's 1 point. The slope of that is
0.
So there's 1 point. What's it doing from here?
Positive.
Positive, and is it big or small?
Big.
It's the slope of this down here, the further I go left, the bigger it is, right? So this is going to be like this, right? And let's look to the right. What's this getting bigger or smaller? As I go to the right, is the slope getting bigger or smaller?
Smaller.
As I go to the right.
Oh, bigger.
The slope's getting bigger because these lines are getting more and more vertical. So boom. And what's going to happen right here? This is called an inflection point right here. See how it's concave down and concave up? That's where the double derivative, that point right there, is where f double prime equals 0. Because that's where the concavity changes. It's called an inflection point. And that's the bottom point of my derivative, single derivative. Right? So what's the derivative of a cubic graph? It's a quadratic. What's the derivative of a quadratic graph? A linear. So this is a linear. So this right here, all right, so I'm maybe jumping ahead a little bit too much. So let's talk about, let me go back and just clean this up a little bit. And let's.
Corey's not. He doesn't know what's coming.
So here's the graph right here. This point right here is going to be, I'm not sure exactly where it's at. It's going to be, let's say, down there. This right there, this right there, and it's going to be
What about him? Like
a quadratic like that.
Okay.
I don't know what's for.
All right, now let's talk about the f double prime. I'll do this orange. F double prime. F double prime of x is the derivative of the purple graph. Well, let's do the same thing.
Okay.
What's the derivative of this purple graph?
Positive.
What's that right there?
Zero.
That's 0. So boom.
Anything fixed up for probation officers.
Right? And what's the slope of these lines right here?
Negative.
Those are all negative slope. And what's the slope of these lines right here?
Positive.
Those are all positive. So the derivative of so what we have here is just we're going to have a single line like this. It's just a line going up from left to right.
Okay.
And what do you notice about the double derivative to the left of that point right there? It's what? Positive or negative?
Positive.
Nope. What are the values of the double derivative to the left?
Negative.
It's negative. And what does that mean about your original graph, the red graph? When the double derivative is negative, what does that mean about the graph?
It's concaving
F
down.
of x is concave down. And look at the red graph. It's concave down.
Okay.
What about when the double derivative is positive,
It's
which
concave
by the way
down.
is right here to the right of that 0, right?
Mhm.
It's concave up, which it is. Look at the graph. The red graph to the right of that is concave up.
Mhm.
That's again an understanding, a visual understanding, conceptual understanding of graphs and derivatives and how they help us understand what the graph is doing and how to go from one to the other. And so now you have to apply those things with all the different ways that they ask the crazy questions in your calc test.